Okay guys, this is the last part of the lesson from today, the one we didn't finish. We did part A, but we did not get to part B here. So here it says given, and it's the exact same information here, right? Now right here, we took the limit as x approaches 2 of f of g of x. Here then, we're going to take the limit as x approaches 2 of g of f of x. Okay, so here's the limit property here. Okay, so then it's a general limit, so you're just plugging in. Okay, so when you plug it into the cubic polynomial here, 2 to the third minus 2 squared plus 4 times 2 minus 1. Simplify all of this, you're going to get 11. So it's just really g of 11 then. So we have what 11 is, what g of x is, so it's just negative 2 times 11, so then you get negative 22. That's your answer. Okay. Now down here, it says use the graphs of f and g, and below and find the limit. So then, the first one here says the limit as x approaches 3 of f of g. So then, here's the limit property. We have to take the limit as x approaches 3 of g. So then, when you go to, here's g, this is the second one, right? When you go where x is equal to 3, here's x is equal to 3. From the left and the right, the general limit, the y value is 1. So then it's really just f of 1. You're going to go to the graph of f. Here's x is equal to 1. The point on the graph is right here. So then that's a y value of negative 2. That's your answer. Okay. For b, the limit as x approaches negative 1 of g of f of x. Here's the limit property. Okay. So then you got to take the limit as x approaches negative 1 of f of x. So here's negative 1. Right, left side, right side, same. They approach the same y value of 6. Negative 6, sorry. So then it's really g of negative 6. Now a couple ways you can do this part here. Okay, so here's g, right? Negative 6 is out of frame, right? We've done this before last year, where you can just count the slope of the line you're working with, and then carefully figure out where it is that you'll be. Okay, or you can figure out the equation of this piece right here of g, right? It is a linear function. Okay, so then that's the equation right here that represents this guy right here, 2x plus 5. So then when you plug in negative 6, you'll get negative 7, and that will be your answer. Okay. If you're confused over how you got the equation, again, rise over run, you'll figure out that the slope is 2. Okay, and then 5 is the y-intercept. If you just keep following the slope up, you'll notice that it would cross 5. So then that's the y-intercept. Okay. Now we'll come back. We'll do this case at the end. Let's do D first. So the limit as x approaches negative 3 of g of f of x. So then the limit as x approaches negative 3 of f of x. So then here's negative 3, right? Left and right side, you approach the same y value of negative 6. So then it's really just g of negative 6, which we saw right here to be negative 7. Okay. Now this last part C here is a different case. Okay. So the limit property is and isn't applied, right? Right here we have the limit as x approaches 1 of f of g. So we have to take the limit as x approaches 1 of g. Okay, but this one is contingent on f being continuous, at least the property is. Now, our graph here, f is not continuous, right? There is a point of discontinuity. So it's going to switch things up just a bit, so pay close attention to how you're going to approach these problems, okay? So as we said, the limit as x approaches 1 of g, when we go here, okay, x is equal to 1 is right here. You'll notice that the general limit for g of x then won't exist, because from the negative side, you approach negative 1. From the positive side, you're going to approach negative 3. So then the limit as x approaches 1 of g of x does not exist. Okay, but it is a function composition, right? There are two possible y values that you did approach as x approached 1, right? From the left and the right. So then, you're going to have to check the left and right limits and make sure that they approach the same y value. Okay, for f, because you are plugging into f essentially, right? Whatever g approaches given the limit. So then, Here's one possible y value of negative 1. Here's the other one, negative 3 from here, okay? And you're going to approach both of them from the positive side because you only need to take that case, okay, and see what y value you approach and hope that they approach the same one. So then, as you approach negative 1 from the positive side, here's negative 1, you do approach a y value of negative 6, and you approach the y value of negative 3, x value of negative 3 from the right side, you do approach the same y value of negative 6, okay? So then, the limit of this entire composition here will be negative 6, okay? Because again, you're taking the composition, right? You want to see what G can be and see if F is continuous, and it is.